Average speed is a measure of the rate at which a moving object describes distance. We represent average speed by the letter v. Now remember, v is also used for average velocity. So we need to distinguish between average velocity and average speed. Now imagine an object is at point A and it moves like this, say to point B. The distance it covered is x. Now the distance is the length of the path, and it took a time interval of t seconds for this distance to be covered. Then we can say v equal to average speed equal to the rate at which the distance is covered. How do we write that? Is x meter, x is measured in meter, divided by t seconds. That is, average speed is x over t meter per second. Now, what is the distinction between average speed v and average velocity v? Well, the distinction is average velocity is a measure of the rate of displacement. Now, the shortest distance from A to B is called the displacement of the object. Now, that is not the same as x, the distance covered. So if I call the displacement as d, then average velocity is the displacement, pardon my sloppy writing, displacement divided by time. It is also measured in meter per second. Now, the distinction between speed and velocity, the most important distinction is velocity has direction. The object travels from A to B. It has a direction. Whereas when we talk about speed, there is no mention of speed. It simply talks about the rate at which the distance is covered. So that's the distinction between average speed and average velocity. All right. So now we know that the average speed v is distance divided by time, v equal to x over t. Now, this can be written, if you multiply both sides by t, I can write this as x equal to v times t. Now, this is similar to the equation y equal to mx. Now, what is the specialty of the equation y equal to mx that you learned in algebra? Well, this is called a linear equation. What it means is that if you draw a graph of y on the vertical axis and x on the horizontal axis, that graph will be a straight line. Oops, let me draw it, see if I can. It'll be a straight line, not like this. I'm using my mouse to draw it, so it will be a straight line passing through the origin. And if you measure the slope of this graph, now what does the slope mean? The slope means change in the value of y, that is delta y, divided by change in the value of x, that is delta x. So the slope is, well, I'm trying to write it over here, slope equal to delta y divided by delta x. Now, in the equation y equal to mx, m is the slope. Now, so what does slope stands for? Slope is a measure of the rate of change of y with respect to x. Delta y divided by delta x. So, if you draw a graph of y on the vertical axis and x on the horizontal axis, it will be a straight line passing through the origin, and its slope will be equal to m. Now, I have asked you in the worksheet, what is the shape of the graph? Now, many of you misunderstand the meaning of the word shape. I simply mean this. The graph will be a straight line. Well, now you know that x equal to vt is an equation similar to y equal to mx. What does that mean? It means if you draw now a graph of x on the vertical axis and t on the horizontal axis, x is in meters and t is in seconds, always use the proper unit. T is in seconds. What kind of a graph will that be? What will be the shape of the graph? It will be a straight line, not like that. It will be a straight line passing through the origin. And if you measure the slope of that graph, that is delta x divided by delta t. What will that represent? The slope of that graph will be a measure of the average velocity. So, our purpose in this lab is to measure the average velocity by measuring the slope of the distance versus time graph. And we will collect our data of distance and time from an animation. All right, let's now go and do the lab activity. Now here I am going to run the car through a certain distance x. You can measure that distance x here, and the time can be read on the clock. All right, let's do the first trial. I'm going to start the car and stop it. This is the first trial. Measure the x and t values. I'm going to reset it. Let's go for the second trial. Stop the x and t values for the second trial. Let's reset it. Start the third trial. There you go. You got the x and t values for the third trial. Let's reset it. Start the fourth trial. There you go. Measure the x and t values for the fourth trial. Let's reset it and go for the fifth trial. All right, measure your values now. Reset it. Let's go for the sixth trial. All right, take your measurements now. Reset it. Let's go for the seventh trial. Stop it. Take your measurements. Reset it. Let's go for the 8th trial. Take your measurements now. Reset it. The last trial. Alright, you have 9 sets of measurements. Find the speed each time. Measure the average speed. Then, I repeat, do a graph of x on the vertical axis, time t on the horizontal axis, and show how the slope is measured. Your graph will probably look like this, and you need to show how delta x is marked, delta t is marked, how the slope is measured of the graph. Now complete the lab worksheet and upload it on in the Lab 2 page.